like this. So peripheral, what did we just get done talking about? Central, which means that the organs we just talked about revolve around where? The brain. Yep. So peripheral means that they're outside the brain and spinal cord. The first one's going to be the thyroid gland. And the thyroid gland is really important to know because are there very many people out there with thyroid dysfunction? There are a ton of people out there with thyroid dysfunction. And it keeps raising. There are a lot of theories why. Like, does it have to do with iodine levels? You know, because it used to be mandated that we had to put iodine in our salt. But now, because of all the health freaks out there, they're like, we don't want anything artificial. So you can buy sea salt that doesn't have iodine. Is that a great idea? No. Not unless you're supplementing somewhere else with iodine. Because what could it cause, not getting enough iodine? You can start growing a second head out of your neck, right? What do they call that thing? A goiter. Yeah, it can cause a goiter. So it's not very fun. Now, this is really weird because the screen here is a totally different color. I can see my glasses have this purple reflection and the screen is blue, and it's just really weird. But the anatomy, you know where the thyroid gland is, right? Where? Yep, it's up here in the neck. It looks like a little bow tie in there. Right, what are the little things in the back of the thyroid gland called? Parathyroids, right. So the thyroid's like a little bow tie in there. The thyroid cells that you want to get familiar with are called follicular cells. So when you break it down and you look under a microscope, and you probably did this in anatomy, you look at the follicles and you can identify the little follicular cells. The follicular cells are the ones that release this this T3 and T4, thyroid hormone. I'm pointing that out because there are other cells in there too that release something totally different. So the anatomy is that the thyroid gland's in the neck. It's set up with a series of follicles, and inside those follicles you have things called follicular cells. The follicular cells actually form a ring, and the ring is filled with something called colloid. So that colloid's full of it's basically a carbohydrate protein molecule called thyroglobulin. It's just like a brief pathway. And then from that thyroglobulin, this is the precursor to make T3 and T4. So you already know thyroid hormone is made from what amino acid is its starting point? Close. It started with T. Yeah, it's tyrosine. So it's made from tyrosine. You start accumulating this tyrosine, you start manipulating it, and you turn it into the thyroglobulin. And then what's going to happen is you have to tag it. It has to be tagged with a special mineral. What's the mineral that I just mentioned that iodine. We have a problem getting sometimes? Iodine. All right. So you have to tag it with iodine. When you get enough pieces of iodine on it, you can release it. If you only get one piece of iodine on it, you can't release it from the thyroid. It's stuck there. It can be stored in that way. When you get the second piece of iodine, it's still stuck there. It can be stored that way. As soon as you tag a third piece of iodine on, now it's called triiodothyronine. Tri means what? 3. Iodo is referring to what? Iodines, and thyrionine is talking about that thyroid molecule. So triiodothyronine is T3. You could release that stuff. But a lot of times what your thyroid will do is tag an extra one on there just in case. So instead of stopping at 3, you can tag a fourth one on, and they call it tetraiodothyronine. And tetraiodothyronine is referred to as thyroxine. What you need to remember about this, when you release these two, you release them both simultaneously, but not in the same proportion. You release about 10 times as much T4 as you do T3. That's the first thing you need to remember. The second thing you need to remember is that the T3 is the more active form. T3 is the one that does the most activity in your body. What's it going to do? What activity am I trying to increase your metabolism? Right. So these two things get released in the body. First is T4, and they could get turned into T3. What does it have to do to T4 to turn into T3? Take a guess. It just has to pluck an iodine off. So I always use that analogy of a grenade with the safety pin in. That's pretty much what it is. The tetraiodothyronine, the T4, is like a grenade. It's not completely active yet. You have to pull the pin. Once you pull one of those iodines off, boom, it's triiodothyronine. That's the most active form. Right. And then the other set of cells in the anatomy are the C cells. And the C cells are easy to remember because they contain a C hormone, which is calcitonin. Calcitonin, guess what mineral it affects in your body? Calcium. Yep. So calcitonin lowers blood calcium. Its job is to lower blood calcium. Where would be a good place to store that calcium? On the bones. I always remember calcitonin tones my bones with calcium. What's that telling me? Is it building up the bones or tearing them down? Building them up. When you tone something, you build it stronger and more toned. So calcitonin tones your bones. It makes them stronger by stealing calcium from the blood and sticking it on the bone. And we're going to talk about calcitonin in more detail later. There's your thyroid. And then, like I said, on the back of this, there are four little points called the parathyroids. If you look at a slide, here you can see that colloid. This whole thing is the follicle coming all the way around. The colloid's the goo on the inside, full of thyroglobulin. And then the follicular cells themselves are the lining that form that circle. They go all the way around. All right. So synthesis, how it's made, and I already kind of walked you through it. It starts with what amino acid? Tyrosine. And then it gets turned into thyroglobulin, which can be stored. And then what do you slowly start sticking on the thyroglobulin? Iodines. Yep. So you can actually store this stuff by not turning it into its final version. The other trick to remember is this is that one exception to the rule. All of the hydrophobic hormones are made out of steroids except this one. What's this one made out of? An amino acid. This is the amine group that's made out of tyrosine. But it's still hydrophobic. Another property about this, which makes it special, it's hydrophobic, but it can actually be stored. You store it by not turning it into the final form. Unfortunately, if you don't get enough iodine, can you ever turn it into its final form? Nope. Remember, you have to have 3 or 4 iodines stuck on it to make it its final form or release it in the blood. So if you just keep accumulating this thyroglobulin and you don't have enough iodine, what happens? You just keep making more thyroglobulin. It's going to get bigger and bigger and bigger and cause a what? A goiter. Yep. So here's the process. Over here in the colloid, like I said, you start with the thyroglobulins. So the thyroglobulin starts here. You start tacking on what? Iodines. So this is just thyroglobulin, no iodine. When you tack one iodine on, here's your iodine, it turns into monoiodothyronine. Mono means 1. And then you tack another iodine on it, turns it into diiodothyronine, which means 2. This is kind of cool how this works. It doesn't just tack a third one on. What it does is it takes a diiodothyronine and sticks it to a mono, which makes a what? A tri. And then it takes that tri, pushes it over here, and it starts pushing it along and stores it until it's ready to release this group. So now it's going to take a couple of those diiodos, stick them together. 2 diiodos make a what? A 4, a tetra. So now I'm accumulating those too. And I'm going to push them along as they get closer and closer to pushing it to the blood. This follicular cell does an evaluation that says, wait a minute, you guys don't have enough iodine to leave, and so it separates them. It pushes the T3 and T4 out, and it recycles the mono and the di. So it pulls their iodines off, and then returns the iodine back out here and starts over from scratch. It's kind of a cool process. Which one of these is more active, T3 or T4? T3. Which one's more abundant? T4. And then I already told you this. So about 90% of the secretory product is released as T4, but T3 is the more active one. So if you're making those flow charts, you want to think of the hypothalamus at the very beginning. Put a little arrow coming down that had TRH next to it. TRH goes to the anterior pituitary and releases what hormone from the anterior pituitary? TSH. Remember, this is still central. And then the TSH goes to where? Thyroid, and does what to it? Stimulates it, hence the thyroid stimulating hormone name. When it gets down to the thyroid, it's going to crank out T3 and T4. This is what starts the whole ball rolling. So these are the stimuli that trigger the hypothalamus to turn on that pathway. Okay? The first thing is homeostasis. So the thyroid hormone level, your hypothalamus is always monitoring. It's saying, do we have 100% concentration of this thyroid hormone? If we have too much, what's the hypothalamus going to think? Shut off. Yep, it shuts it off. And then you slowly start burning up your thyroid, and when it gets too low, what's the hypothalamus think? Turn it back on, turns the pathway on. So you always want to keep it at that 100% level. So if you take artificial T3 or T4, what's going to happen to your hypothalamus? It starts turning down. Yep. So, which is kind of a sucky loop, right? Because if you're taking the T3 and T4, you're probably not making enough in the first place, but what's going to happen to you? It's just going to turn lower. Yeah. Right. Second, a calorogenic effect. The real word calorie in science means heat. So a heat generating effect. If your body gets too, cold, it turns on the pathway. So a colder temperature turns on the hypothalamus. Its overall effect, its final effect is to warm up the body by doing what to your metabolism? Raising the metabolism. And this intermediary metabolism, this is talking about what it does to carbs, fats, and proteins. So if you're trying to generate heat and you're trying to burn energy, what are you going to do to your fat? You're going to break it down. So it has a catabolic or destructive effect on your adipose tissue. What's it going to do to your glycogen stores? Break them down. It's trying to burn everything for heat and energy. What's it going to do to your proteins? Break them down. It's trying to burn everything for heat. So what happens to the size of these people that have too much thyroid in their body, too much thyroid hormone? They get skinnier. They get scrawnier in general. Muscle mass starts getting smaller. Their adipose cells start getting smaller. So I always think of the thyroid hormone, if it's trying to keep you warm and that's its main goal, if your house is freezing and you're freezing to death, what are you going to throw in the fire? Everything. Everything goes. It's fire sale, right? So you're throwing everything in. You're throwing your chairs, your table, everything. That's what the thyroid's doing to the body. If you have too much thyroid hormone, it's burning your sugars, it's burning your fats, it's burning your proteins, it's trying to save your life. The next effect it has is called sympathomimetic. What's mimicking mean? To act like something, right? So sympatho, what's it acting like? The sympathetic nervous system. What's it going to do to this person's anxiety levels? Lower them or raise them? Raise them. What's it going to do to their blood pressure? Raise them. What's it going to do to their pupils? Dilate them. All the things you already know about the sympathetic nervous system, this is actually helping increase the activity of epinephrine. So the thyroid hormone itself doesn't cause this person to sweat or get anxious or anxiety. It's the combination of the thyroid and epinephrine. Thyroid's like fire on the or fuel on the fire. If somebody already has high thyroid, they can be relaxed, calm, their blood pressure's fine. Boom!
Oh my God.
But as soon as something scares them and they release that little bit of epinephrine, what happens? Their epinephrine plus the thyroid is explosive. Just testing to see how many people have hyperthyroidism. But yeah, you take these people to a scary movie, the first time that somebody jumps out from a closet, they're like sweating and they're climbing over the chair. Like, God, I can't believe I came into this. I can't handle this. And then you're like, shh, right? Calm down. But it has a sympathomimetic effect. It turns up the effects of epinephrine. So a little bit of epinephrine goes a long, long way in these people. Right, next effect. People are still like moving, going, oh my God. Effect on the cardiovascular system increases the heart rate. You already know this. If it's sympathomimetic, what's it going to do to your heart rate? Increase it. What's it going to do to your blood pressure? What's it going to do to your sweating? Right. I see people going, God. Exactly. Airing out the armpits. Thank you. I guess I'm not worried about it. Two people next to you have to worry about it. So, and then effect on growth and nervous system. I already told you, thyroid hormone does what for growth hormone? Antagonist, permissive, or synergistic? It's permissive. It allows growth hormone to work. So if you don't have enough thyroid hormone but you have plenty of growth hormone, what happens to your stature as a kid? You don't grow. Yeah. And I think that's where we're stopping for today.